Okay. All right, so let's start with number one. This is on page 7. We're going to today just work through pages 7 through 10. So it says let R be the region in the first quadrant bounded by the graph y equals 2 root x. You see that curve here. The line y equals 6, that's a horizontal line, and the y-axis. Find the area of R. So whenever you see an area problem, sometimes there's an option for you to either decide between top minus bottom or right minus left. And so students have asked, so how do I know which one to use? You want to look at what's given to you. If your equations are given to you as a function, then typically you want to explore the option of top minus bottom first. But if the equation is written in terms of x equals, and you see it's a tough equation for you to rewrite, then it's going to be most likely right minus left. But in this case, some problems can be done both ways. So this can be done as top minus bottom. It can also be done right minus left if you just rewrite these equations. It's possible. So for practice, though, let's try top minus bottom first. And then once we get through A, B, and C, maybe we can also try it right minus left in this space that we have here. But let's start off top minus bottom for area. So go ahead and try that. And we're going to try to do this without a calculator, just so that we can get that. I don't want us to forget that process, but it's asking just for A, you're going to solve it off by hand. For B and C, you're just setting up the equations. Okay. All right, go ahead and try that, and then we'll walk through the steps, go through the solution. You guys also have the key on you as well. Okay, top graph is that y equals 6. The bottom graph is that y equals 2 root x. So area is just a depth integral from the left x value to the right x value, top minus bottom, those squared. Okay. And we're going to try to work this out by hand. So get that second term rewritten so that you can clearly see the need for power rule for both terms. And then apply power rule twice, once for each term. And then you can work in the bound, right? The 9 gets inserted into the antiderivative minus, then you do the zeros. Any questions with the steps so far? Okay, 6 becomes 6x, 2x to 1/2 becomes 2x to 3/2, so the 3/2. upper bound gets inserted first. 9 in for the x's, minus big parentheses, and then 0 in for the x's. Technically, on the AP exam, you should be leave your answer in this form and they'll give you full credit. But for now, let's just see if we can get it all the way down to a numeric answer. I want us to be able to know how to do this here. 9 to the 3/2, that seems like a difficult thing to do, right? 9 to the 3rd power. That's such a large number, and then take the square root of that. What's an easier way to do this without a calculator? Yeah, do the square root first, right? Square root of 9 is 3, and then do 3 to the 3rd power. That's 27. That's a lot easier to do without a calculator. Okay. But just want to just let you know, AP exam does not require you to resolve your numeric answer. However, if you plug in your bounds and you get like cosine of pi over 4 minus, sine of pi over 4, then they would expect you to get it down to numeric. You got to resolve the trig down to a ratio before you can leave your answer unsimplified. So, okay, any questions with A? Now, we'll save the top space after we get through this to attempt A from a right minus left perspective, just so we can get that practice. Okay, part B, write but do not evaluate the integral expression that gives the volume of a solid generated when the region R is rotated about the horizontal line y equals 7. So y equals 7 is going to be off of that shaded region. Notice that dotted line is off of that shaded region. Now, if that axis of revolution was right at y equals 6, then it'll be this method. But since it's not even touching the graph, it's not up against a flat surface, there's a gap. Because of that gap, we have to subtract out the whole. So top minus bottom from the axis all the way to the curve, that's your big R. From the axis to the y equals 6, that's your little r. Top minus bottom for both. And your bounds is from 0 to 9. Some students have been asking about how do you know for the bounds, if the bounds are not given to you, how do you know when to look at the graph? How do you know when to use intersection between two curves in your calculator? So just to kind of point out a few things here that I have up on the board. If you're looking for the intersection between two curves, then typically you set the equations equal to each other. If you can't solve it by hand, then you can use your calculator and find that intersection between 2 points, and that will help you get what to your boundary, either as x or in terms of y, depending on what you need. But if your boundary is the x-axis, x-intercept between the graph and the x-axis, then you would set the function, the curve, equal to 0 and solve for x. If you can't do it by hand, then you would use the 0 feature in your calculator and look for that x-intercept. If your boundary is the y-intercept, you're not going to be able to graph this. But what you can do is you can just insert 0 into the function, into the x value of the function, and then just solve for y. So just replace 0 for x, solve for y. Either use your calculator or work it out by hand. Whatever that y value is, that's the y-intercept. So this is the one thing that you really can't graph, but it should be hard to find that y-intercept if you needed it. This is just asking for the setup, so we can stop after we create our volume formula. Top minus bottom for big R, top minus bottom for little r. Make sure you're squaring your radius separately. Now, technically, this is still doable by hand. It's just a little bit tedious. You have to FOIL all this out, clean all this up, but everything can be done with Powerful. It's just a lot of terms. And then plugging upper and lower bounds. So typically on the AP exam, I don't see them usually asking students to do this by hand. But they've done it before, but it's pretty rare. Usually it's okay, just set it up and they'll ask you for the steps for the area, but usually if it's not a calculator, they'll just ask you for the setup. But technically, they could ask you to work this out because it is manageable by hand, and you can just expand this out into Powerful. Okay, part C. Region R is the base of a solid. For each y value between 0 and 6, the cross section of the solid taken perpendicular to the y-axis, right? You always have to pay attention to what direction they're asking you to draw this in. So perpendicular to the y-axis, which direction is that? Is that vertical or is that horizontal? Horizontal, yeah. So y-axis is vertical. Perpendicular means I got to change direction to make it horizontal. So I know it's going to be right minus left. If it's right minus left, we know we have to spend time to rewrite our equations. It's a rectangle. Rectangle is base times height. We'll find the length of the base, and then they're describing what the height is. The height is 3 times the length of the base. So we'll find the base. We'll find the height, which is 3 times whatever the base is. We'll multiply that together, get that area formula, put integral around it to make it go up to a volume, and then our bounds also in terms of y. So the y equals 2 root x is not in the proper form for right minus left, so we have to spend time to rewrite it. That x by itself, so divide by 2. Square both sides to get solve for x. X equals y squared over 4. That is my right, the curve on the right. The left endpoint is sitting at the x equals 0. So then we do y squared over 4 minus 0. So I have my base built. Height is 3 times the base, so 3 times y squared over 4. Area is base times height, so I'll multiply all this together. And I just put an integral around it from 0 to 6, and that's my setup for my volume. Okay, for at the very top, if you can call this A part 2. And let's do part A again, but then do using right minus left and just do it by hand. We should be able to get the same answer as well. We try to do this right minus left. Part A. Our bounds is going to be different. Our equations are going to be different. We go through power rule still, plugging upper and lower bounds. We still get 18. All right, go to page 8. Read the problem, see if you can see how far you can get, and I'll go through the steps. Guys, technically area is units squared, volume is units cubed. But on the AP exam, if they don't specify that they want units, they're not going to, they can't take any points off if you don't provide units. So if they are gonna count for units, they're always gonna mention it. So. Function.
Minus zero by conclusion. Right. Like.
Yes, yeah, so. That's what yeah. Right is y squared over 4, my left is 0, so it's y squared over 4.
Wait, so it's in like. After it's rotated.
Which part are you on?
No, part C.
Part C, there's no rotation. Part C, it's a cross section. So we're just, imagine this is a flat surface and we're building rectangles that sit on top of it. So there's no rotation. In cross section, we're going to be using. Open this down.
Yeah.
Guys, number 4 is also meant to be non-calculator. So after you set up part A, see if you can go through the process, but you have to go through U substitution. Okay. So you know you need U substitution if your problem looks too complicated for any one rule to handle. So your U value would be the x squared, which will handle that x that's sitting out in your eventually working towards the e to the u rule. Trying to take a complicated looking problem and mold it into something that is usable. And then you apply the interval rule that so my u value is x squared. Du dx is 2x, solve for dx, dx is du over 2x. I make my substitution for the x squared and for the dx. I'm leaving that 2x alone. That 2x is going to be a separate power rule. So once I make my substitutions, I can get the x to cancel out. The 2 is going to remain. So I have 1/2 e to the u, which becomes e to the u. We don't do a plus c in this case because this is a definite integral. So we do 1/2 e to the x squared. So that's my antiderivative. 2x becomes 2x squared over 2. So I have both my antiderivatives, and now I'm ready to insert my bounds. Upper bound gets inserted first to the full expression minus the parentheses, and then plug in the 0. So you gotta be careful. A lot of times we see the 0 and we assume that 0 is just going to take everything away. But in this case, that e to the 0 is still going to be some leftover, right? Anything raised to 0 power is not 0, it's actually 1. So you get a minus 1/2 minus 0. So there's still that negative 1/2 that's going to remain. So 1/2 e plus 1 minus 1/2 is equal to 1/2 e plus 1. Again, you're not going to expect to see this type of problem on the test because you'll get to use your calculator, but I don't want us to forget how to do these, go through these steps. Okay, part B is asking you to just set it up. Part B is washer method, top minus bottom. There's an obvious gap between the axis and the shaded region. So we need 2 radius. That's the root of it. The integral is just this. Just that, yeah. Okay, if you're good with this, next page. You have all these problems being non-calculator. So for A and B, you're going to set it up and solve, but for C and D, you can just set it up. Okay, so they give us a problem as top as two functions, so with top minus bottom works. Since we're not gonna have any conflict with no matter where you draw your rectangle, the top is always hitting the line, the bottom is always hitting the curve. Top minus bottom, no need for use substitution. Both terms can be set up using power rule and then plugging the upper and lower bound and get it down to a numeric answer. Now, part B feels a little bit weird because typically with cross section, they'll tell you information where you can build a base, and then from the base you build the area. But in this case, they already gave you the area, so you just have to put integrals around it. So you don't have to formulate any area because they already gave that to you. So just have to work out this problem, which we have integral rule for sine of u, but we don't have integral rule for sine of pi over 2x. So we have to go to use substitution, get that to clean up to be a sine of u du, and then we can figure out, do this what's the leftover coefficient, plug in upper and lower bound, and get it down to the numeric answer. So our u value is that pi over 2x. We're trying to get it down to sine of u du. Du, u is pi over two x, the derivative is just pi over two, right? We just push that coefficient out in front. That's the only thing that remains because the x drops out. Solve for dx. Cross multiply first, so pi dx equals 2 du. Solve for dx, dx equals 2 over pi du. And your substitutions, sine of u, 2 over pi du. I can push that coefficient out in front. Once I get past that coefficient, it matches perfectly with the rule that I want to use. Sine of u is negative cosine of u. Right, with integral, we talked about how we look at the antiderivative and we look to see, does it produce a c in this antiderivative? If it does, you know there's going to be a negative in front. So negative 2 over pi, cosine of pi over 2x. You bring back your u value. Now you can, you bring back your x value, then you can plug in your bounds. But on the AP exam, you can't leave your answer as cosine of pi minus cosine of 0. You got to get it down to a numeric value. So cosine of pi is -1, cosine of 0 is 1. You can leave your answer like this. You don't have to simplify your numeric answer, but you can't have your trig showing. You got to get that trig resolved. Okay, for part C, now this feels more familiar. It's a cross-section problem, but it's cross-section where you can build the base, find the area. Okay, so B and C are both cross-section, but D is a little bit, feels a little different because you have to build the base, you have to understand what they give you is the area, and you can just put the interval around it. But part C feels more familiar. But C and D, you're just setting it up, and then that's good. That's it. Don't have to go any further beyond that. Both C and D requires a right minus left, so we have to spend time to rewrite the equations that y equals 2x and y equals x squared are not in the correct format, so you gotta solve for x. Make sure you spend the time to algebraically solve for x. You can't just replace the x with y and y with x and just let that be your equation. That's, you would do that if you're trying to find the inverse, but you want the same equation just in a different form, so you gotta move things around and get that x by itself. And then part D is washer method. There is no flat horizontal or vertical surface on the shaded region, so no matter where the axis is, it's always going to be a washer method. But both C and D are horizontal, so you can reuse a lot of information. Same bounds, same equations. Okay, we didn't quite get to page 10, but tomorrow we'll finish up page 10. And then I'm gonna start AP review. I'm gonna save the last 3 pages for Friday morning. For you to practice Thursday night for the test. But tests will be on Friday. Tomorrow we'll start AP review. Okay. All right, you come and get your phones.
So